Welcome to This Explainer. Today, we're tackling something that usually strikes absolute fear into the hearts of students. But honestly, it's actually one of the most fascinating, incredibly practical tools in all of mathematics. We are demystifying trigonometry. And I promise you, we are going to do a complete, entirely stress-free breakdown. We're starting from absolute scratch, assuming you know zero about the topic, and by the end, you're going to be completely conquering those ultimate identities. It's going to be a really fun ride, so let's get started.
Think about this for a second. How exactly do we measure the height of a towering monument, like the Qutb Minar, or figure out the width of a wide rushing river, without, crossing it with a giant tape measure? It seems literally impossible, right? Well, that seemingly impossible task is the exact reason this branch of mathematics was invented in the first place. By simply observing an object from a distance, finding a specific angle, and doing a tiny bit of calculation, you can pinpoint its exact height or distance. That real-world magic, that's what trigonometry is all about. Let's just break down the word itself, because it's actually a Greek mashup. Tri means three, gon means sides, and metron means measure. So right at its core, please don't let those complex equations intimidate you. This entire subject, the whole shebang, is just about exploring the relationships and the measurements between the three sides of a right-angled triangle. It really is that simple.
Here is our roadmap for the journey today. 1. The right-angled toolkit. 2. The magic angled table. 3. Complementary angle secrets. And 4. The ultimate identities. Okay, let's dive right into this. Section 1. The right-angled toolkit. Building the foundation.
Listen up, because this is where so many students trip up. Perspective changes everything. In any right-angled triangle, the longest slanted side is your hypotenuse. That's locked in, it never changes. But the perpendicular and the base, actually, wait, let me emphasize this. They completely swap depending entirely on your perspective. If you're looking from angle A, the side completely across the triangle is your perpendicular, and the side right next door is your base. But shift your eyes over to angle C, and suddenly the side opposite to C becomes your brand new perpendicular. The golden rule here? Always lock down your angle of perspective first before you start naming your sides.
Okay, so once you know your sides, you got to know their ratios. Let me introduce a master trick that's a total lifesaver in Indian classrooms. Just remember Pandit Badri Prasad Har Bole, Sona Chandi Tol. The first letters line up perfectly. P over H, B over H, and P over B. And that's Sona Chandi Tol at the end? That hands us our trig functions, sine, cosine, and tangent. This simple, catchy little phrase is the anchor you need to easily lock down those primary ratios without mixing them up.
So let's map that out into actual math. Pundit over har maps directly to sine, which is just perpendicular divided by hypotenuse. Badri over bol gives us cosine, which is base over hypotenuse, and Prasad over bol gives us tangent, which is perpendicular over base. Boom. If you know these three, you've got your foundational toolkit. And here's a quick bonus for you. Those other three ratios you might hear about, cosecant, secant, and cotangent, they are literally just these exact same fractions flipped upside down.
Quick detour though. Before we start calculating those ratios, there's one classic rule we absolutely have to remember, and that's the Pythagoras theorem. Hypotenuse squared equals perpendicular squared plus base squared. Why does this matter so much? Well, if a real-world problem only gives you two sides of a triangle, you have to use this key formula to track down the missing third side before you can even touch your sine, cosine, or tangent ratios. It's an absolutely essential stepping stone. Section 2. The magic angle table. Specific values. Now, ratios are fantastic if you actually know the side lengths. But what if you're only given a specific angle? Please, forget blind memorizing that intimidating row of values for 0, 30, 45, 60, and 90 degrees. I'm going to show you a genius little trick. To find your sine values, just write down the numbers 0, 1, 2, 3, and 4. Next, divide each of those numbers by 4. Finally, just take the square root of each result. And just like that, you have magically generated your sine values without memorizing a single scary fraction. No way, right? It works every time.
Take a look at how these numbers play out. See that top sine row we just calculated? 0, 1/2, 1 over root 2, root 3 over 2, and 1? The rest of the table practically completes itself. Check out the cosine row. It is literally just the sine row written in reverse. The 1 moves to the front, the 0 goes to the back. And tangent? Tangent is simply the sine value divided by the cosine value. 0 divided by 1 is 0. Just divide straight down the columns and your table is fully built. It's like a giant, super satisfying math puzzle.
Section 3. Complementary Angle Secrets, the 90-degree mirror.
Don't you just love when math practically hacks itself? In every single right-angled triangle, the two non-right angles must always add up to exactly 90 degrees. This creates this awesome mathematical mirror. If you have the sine of 90 degrees minus an angle, it magically flips into the cosine of that angle. And it works in reverse too. The cosine of 90 minus an angle instantly transforms right back into sine. By simply subtracting your angle from 90, you can flip a frustrating sine problem into an easy cosine problem, and vice versa. It's an incredible shortcut.
And hey, this isn't an exclusive club for sine and cosine. This exact same 90-degree mirroring rule applies across the board. Tangent pairs perfectly with cotangent, and secant pairs perfectly with cosecant. So anytime you see a 90 minus theta hiding in a tricky equation, just remember the mirror, swap the function, and simplify your life.
Finally, Section 4, the ultimate identities, the final boss.
All right, take a deep breath, everyone. We have arrived at the final boss level of trigonometry. This single, beautiful formula is the universal truth of this whole chapter. Sine squared theta plus cosine squared theta equals 1. No matter what angle you plug into that theta, whether it's 30 degrees or 89 degrees, this equation holds true. So the crucial takeaway here is that you can use and manipulate this single identity to substitute values and solve almost any advanced, scary-looking proof they throw at you on an exam.
That master identity branches out into two other main rules, basically connecting tangent to secant and cotangent to cosecant. If you ever need to isolate sine squared, well, just shift cosine over to the other side to make it 1 minus cosine squared. You are completely equipped now. These are the absolute final pieces of your puzzle-solving toolkit.
Wow, from understanding your base ratios and building that magic table to complementary mirrors and ultimate identities, we've really broken down the whole structure today. You now possess the mathematical toolkit required to decode the architecture, the monuments, and the natural distances all around you. So I want to leave you with a thought. Look out your window right now. Where is the nearest right-angled triangle waiting to be measured by you? Keep questioning, keep observing, and I'll catch you on the next explainer.